Greetings. Welcome to my presentation on teaching cloud computing and digital business transformation using my hands-on virtual computing book with MindTap. I'm Ted Simpson, Cengage author and adjunct computer science instructor for UW colleges. Over the years, I've written a number of books for Cengage, including books on Novell NetWare back in the 90s, then Windows operating systems, and more recently, virtual computing, including the latest edition of our Hands-On Virtual Computing book. Well, what is digital business transformation? How does it relate to the cloud? Well, according to Enterprise Project, digital transformation is integration of digital technologies into all areas of the business, thereby fundamentally changing how you operate and deliver value to the customer. And cloud computing is a major part of implementing this new digital transformation. Well, digital business transformation is not exactly new, is it? In the past, digital business transformation included technologies like punch cards back in the 50s, mainframe terminals and mini computers in the 60s and 70s, and then in the 80s, we have the microcomputer, distributed processing. The 90s, you have the file and print servers, the Novell era, if you will. But more recently, digital business transformation today involves technologies like virtualization, hyperconvergence, virtual desktop infrastructures, and public cloud services. So then, what technologies do students need to learn about in today's digital business transformation environment? First of all, virtualization. Virtualization is a fundamental technology used in almost all data centers today. And that's actually part of a bigger picture called hyperconvergence, where we define these hardware devices and software, allowing us to create software-defined data centers. These software-defined data centers can then be plugged into cloud computing services to extend their capabilities and add new applications and reduce costs. This all leads to device mobility and the ability to implement new applications and technologies quickly, things like artificial intelligence, big data, and deep analytics. But none of these technologies are going to be usable unless we add security. And the cloud can enhance our cybersecurity by implementing a number of new capabilities that are available in the cloud. Hyperconvergence sounds like something out of Star Wars or Star Trek, but really it's an infrastructure model in which hardware devices are represented in software structures, making them independent of the specific device. First example mentioned is virtual machines and virtualization of the actual compute resources. Then you have hyperconvergence of the networking, the software-defined networking, for example, of networks and data, such as storage area networks, and then the public cloud storage and other services that are available in the cloud. Virtualization then is really a hyperconvergence process. It uses a software layer called a hypervisor to create a virtual structure consisting of the hardware resources or compute resources like the CPU, the memory, the storage device, the network. All this can be rolled up into a virtual machine, which basically is a computer defined in software and can be moved between various hardware environments. And this concept dates back to IBM era. IBM mainframes in the 1970s pioneered some of these virtualization concepts, later used by VMware in their workstation product in the late 90s. That brings us to cloud computing. What do we mean when we say cloud computing service? Well, according to the National Institute of Standards and Technology, NIST defines a cloud environment as consisting of the following 6 characteristics. First, on-demand self-service. This means the ability for consumers to quickly provision virtual machines, with the hardware and software resources they need, and allowing them to do this automatically without waiting for outside assistance. Broad network access means that these services are available using a web browser or some standard interface, essentially from any location over a variety of devices. The third one, resource pooling, applies to the hyperconvergence of hardware devices into pools, allowing for on-demand access to the consumer. Elasticity means that these resources from the pool can be quickly scaled in and out of the user's environment, and the user only pays for the resources they use in a given time period. And finally, a cloud service should provide redundancy and fault tolerance, as well as the capability to implement load balancing and disaster recovery. So all 6 of these characteristics rolled together are what we call a cloud computing service. And there are various ways we can implement this. In a private or community cloud, our on-premise data center is used to implement these services to our own departments in our business or our organization. In the community, these services could be made available between members of that community. But still, they're hosted in the on-premise data center and for a select group of users. IDG says 20% of IT spending by 2020 will be in this private community cloud environment. The other type of cloud service is a public cloud service, provided by cloud service providers such as Microsoft Azure, Amazon Web Service, IBM Cloud, Google, and others. They provide this service for a fee to outside organizations. Then a hybrid cloud is a way in which we can take our on-premise or private cloud and extend it into the public cloud. 32% of IT spending, according to IDG, will be in this area of hybrid clouds and public clouds by 2020. The advantage of using public clouds over private or on-premise data center, one of them is agility. You can very quickly and easily move and implement applications, take them on and offline. Scalability, you don't need to buy a bunch of hardware you don't use all the time. You can automatically scale based on the load that you have. And of course, this can reduce costs, basically our setup costs, but also our operational costs. And disaster recovery. A lot of businesses are moving towards the public cloud, and that's one of the major advantages they see right off. Also, implementation of new technologies. Artificial intelligence, big data, and deep analytics I mentioned earlier. It costs quite a bit to do this in your on-premise data center. You'd have to probably add additional hardware, but also software, and then the training or new personnel you may have to bring in that have the knowledge to actually implement these systems correctly, where these systems can be made very easily to implement by plugging into our existing cloud services. And of course, we can use the public cloud to extend our on-premise data center. That's referred to as infrastructure up. Or you can replace parts of your on-premise data center, or in some cases, certain businesses might actually be able to replace their entire on-premise data center with a cloud down strategy. The cloud also brings in a new type of worker that's important to the workplace. This is called the cloud, or gig worker. And this worker works each day in a fully cloud-enabled environment with access to enhanced tools, including artificial intelligence, big data, and deep analytics. So what is a gig worker? Typically, they're independent workers. They may be, self-employed, so to speak. But they have become an essential part of many firms, especially because they can bring in highly specialized skills and possibly work with just certain project groups to enhance the implementation of these projects. Most of the work done by the gig workers through a web browser. So today, businesses need to be able to provide a cloud infrastructure for gig workers that allows us to take advantage of their skills and yet still protects our company from, them getting access to a lot of the data and things they don't need. So there's a lot of infrastructure necessary to make this work correctly, but it's very important if our organization is going to be competitive with other organizations and utilize a lot of these workers' capabilities. So our students then need to understand and be part of this whole environment. So then how do we teach all this digital transformation and cloud infrastructures? Well, we've got to start someplace. And as you can see in this diagram, the cloud and virtualization have an area of overlap, where virtualization skills also become part of cloud skills. So it's important that all students have a good foundation in digital business transformation, virtualization, hyperconvergence, software-defined data centers in order to move into the cloud certifications. And we can provide those skills in our Hands-On Virtual Computing book, allowing students a lot of hands-on interactivity. Our textbook is designed around three major teaching objectives. First, to allow you to implement a hands-on approach to help increase student interest and retention. Second, to allow you to teach multiple products that are popular in industry today, and also to provide some flexible curriculum options to make it easier for you to implement these things in your existing courses. For example, you may include Chapter 1 into an Introduction to Computing course. Chapters 2 through 4 would be good information that you may like to include into an operating systems course, a Linux course or a Windows course. If you have an existing Windows Server course, which most schools do, you may want to include activities or materials from our chapters 5 and 6 on Hyper-V. And then if you have a VMware course or setting up a digital business transformation course, then chapters 7 and 8 deal with VMware and vCenter Server with lots of activities in there. And then in chapter 9, they get a chance to experience virtual desktop infrastructure, and then in 10 to carry these into the cloud environment. And now they're ready to move into a more specific cloud course, which might help prepare them for like the CompTIA Cloud Plus certification. So in summary here, we can have students purchase a book if you like, and then they could use that book throughout a few different classes by including chapters from the book. Or if you're currently using Cengage Unlimited, it's very easy to plug modules, as I've shown you here in this diagram, into specific courses. And since the students already purchased the Cengage Unlimited, they have access to all these modules at no additional cost. So thanks for listening to this presentation, and have a great semester.